5.3, we're going to add, subtract, and multiply polynomials. In my opinion, this one's quite a bit of a break compared to 5.2. Graphing is one of the harder things that we do with polynomials. First example says add these two polynomials in vertical format. So I'm going to write them up in vertical format, which really means just line up on top and bottom degrees. So take a look at what that means. Notice I didn't put anything underneath the 3x. That's because the second polynomial didn't have an x term. The reason this is a nice way to add things is everything's lined up. We can just add straight down. 2x cubed and 1x cubed, 3x cubed. Negative 5x squared and positive 6x squared, positive x squared. 3x was by itself, and plus 2. We're done. We added the polynomials. Part B says add in a horizontal format. It's a little different looking. Means we're not going to line them up on top to bottom. Let's take a look at what horizontal format looks like. Horizontal, as you might have guessed, means just write it all out in a straight line horizontally. Here you just have to still match up degrees that are the same. See a 3y cubed over here, but no y cubed on the other side. Go to my next degree, y squared and a negative 4y squared. Keep going, get a negative 7y and a 2y, and the minus 5 is by itself. All that's left is collecting like terms. Because of the plus sign, we don't have to have any difficulty. We're going to see minus in a little bit. That means we have to distribute the minus sign. But for right now, nothing like that. We just combine like terms. Let's see what we get. Try this on your own, maybe. Pause. And that's it. You can choose whatever method you like the most, unless the directions say to do something specific, in which case I'm checking to see if you understand the idea. Next up, we're going to try subtracting vertically and horizontally. Before you even do the addition or subtraction in this case, see if you can set up both of these. And I'll check in with you before you go on and simplify. So pause the video and set these up. Couple tricks. Maybe you got the wrong thing on top and the wrong thing on bottom. Go back and read what it says carefully. It says we're subtracting this guy from something else. If I told you to take 2 from 5, you wouldn't write 2 minus 5. You'd write 5 minus 2. So I almost made that mistake myself, caught myself and fixed it. The other thing that's important is the parentheses. You need those parentheses there to tell you that you're distributing the minus sign to everything inside the parentheses. Instead of 8x cubed plus 3x cubed, we have to say 8x cubed minus 3x cubed. Negative x squared minus 2x squared, and so on. So go ahead and pause the video and try cleaning these up, combine like terms, see if you get the same thing as me. Overall, addition and subtraction are pretty much the same thing. You just have to be a little more careful with the subtraction. At this point, you can pause the video and try a couple of these on your own, or you can do that later. Okay, next up, we're going to multiply polynomials vertically and horizontally. Once again, neither way is necessarily right compared to the other way. It's just a matter of preference. So let's see what this looks like. This time we don't have to line up degrees because we're not adding straight down. Let's take a look at what it looks like. We're going to say negative 2y squared plus 3y minus 6 times y minus 2. That's vertical format. Horizontal format would look like this. X plus 3, 3x squared minus 2x plus 4. Either way, we're going to distribute everything in the first set times everything in the second set. In other words, first thing I'm going to do is multiply all this stuff by negative 2. Then I'm going to multiply all that same stuff by y. Then I have to collect like terms. So I'll multiply by negative 2 and then check in with you. I'll also multiply by y before I check in. Pause the video, try this on your own. Notice I was still lining up my degrees on the next step. That way when I add these together, I'll have my degrees lined up and I can just write out my answer without too much difficulty. This is just like multiplying with numbers. hard mode. That's it for part A. Part B, as you're distributing this x to this whole thing, and then the 3 also to the whole thing, go ahead and be sure to choose whatever method you like. If you want to line up the degrees that match, line them up. If you'd rather use horizontal adding, do that. Either way, you should get the same answer I do. Check in with me after you pause and try it yourself. And that's it for that one. Now we're going to multiply 3 polynomials together in horizontal format. So this is just really more of the same, just making it a little harder. Your first strategy might be to multiply these two together, and then whatever you get, multiply by x plus 3. It's going to take a little work to get that inside piece, but you should already know how to do that, whether you're using the distributive property or FOIL. Either way is okay. Then you're going to multiply that piece by the x plus 3. Go ahead and see if you get the same answers as I do. If you're not getting the same thing I am, go back and check all of your signs. Okay, some special products that we should recognize from our factoring chapter. We've got perfect square binomials, we've got difference of squares, and we've got the sum of cubes and difference of cubes formula. We learned how to factor with all of these in the past. Now we're going to just use them to multiply out. So we can memorize formulas instead of actually using FOIL or something similar. If you don't want to memorize these types of formulas, you don't have to. You can just multiply them out the way we did in the last few examples. Just might save you a little time. For instance, I see in part A, it looks like we have that difference of squares format. So I'm going to want to use the a squared minus b squared type formula, which in this case becomes 9t squared minus 16. Looks like a perfect square binomial in part B, so I could write out something like 64x squared. In the middle, we're going to have the minus 2ab which ends up being negative 2 times 8x times negative 3, which is negative 48x, and then b squared is 9. Part C, we've got the sum of cubes formula, which we will have to know the formula for a sum of cubes, but we don't have to know it to do this problem. Then we just have to plug everything in. This is probably the hardest one, but it's good practice. See if you get the same thing I do. Go ahead and pause the video for that. That's it for that one. Now we have a beast of a word problem to worry about next. But first, you can try some of these on your own or do them later. Alright, go ahead and pause the video and see if you can set up the product for this one. The hint is it's a product because well, go ahead and read it and see if you can figure out why. Let's talk about why this is the correct formula. That first equation, W, as we can see in the description, tells us how many thousands of whales we have. So this is the number of whales we have in thousands. Then each whale produces a certain output, as we see here. That's how many barrels we get per well. So if you want to find out how many total barrels we get, we're going to have to say how many wells we have. That was the first highlighted piece. And how many barrels we get per well. So we're going to get some big number times some big number, get a total number of barrels per day. And if you're looking at that and thinking it doesn't sound very fun to multiply out, we are in agreement. I would recommend you use a calculator. Be careful. Just multiplying a bunch of decimals, but you'll get to it. See if you get the same thing as me. I'm not going to round at all for this next step. What a mess, am I right? Next, we want to find out how much crude oil is produced per day in 2000. We don't want to plug in 2000, we want years since 1980. It's been 20 years since 1980, so we're going to plug in 20. And we get 558 about. That's not how many barrels we did. That's how many thousands of barrels we did. So to get the actual number, we have to multiply by 1,000. There's really 5.6 million barrels produced per day. That's a lot of oil. That's it. Probably the messiest word problem we've seen in a while. At this point, you can try this problem on your own, or you can do that later.